This will be the third video in the review session for Test 3 Fall 15 for Math 110. This is homework problem number 6 from homework number 8. So we're looking at function notation here. Let me make sure that I have not started on the wrong problem. Yes, 6 is where we want to start. So let me get back to that. So function notation, we're going to find the function value of this function, negative 1/2 x plus 3. And we want to do that when for f of 0. Now what we want to realize is that what that means is that I'm finding when x here is replaced with 0. So what this means is x is equal to 0. So remember, this is the shorthand way of saying what we used to say as let x equal 0 and then find the value of this expression over here. So we're going to do that by substitution. So this says negative 1/2 times 0 plus 3. And therefore, we have 0 here and 0 plus 3, which is 3. So f of 0 is equal to 3. Now the next thing that we're going to do is we're going to find when f of x is equal to 0. Now what that means is that we're going to let the function equal to 0. So this thing is getting replaced by 0. That's what that equals. So that says 0 is equal to negative 1/2 x and then plus 3. So when we look at that way, then what we're seeing here is that we're solving this for x. So I'm going to add negative 3 to both sides, and this one is giving me negative 3 is equal to negative 1/2 x, and then I have to get rid of this, so I'm going to multiply by its reciprocal, a negative 2, multiply by its reciprocal, a negative 2, and then this is going to give me that x is equal to positive 6. Now I'm pretty sure that these two problems were not those, but this one up here. And part A also asks us, what am I finding when I'm doing f of 0? And the answer to that question of what I'm finding is this is when x is equal to 0. That is the constant value in slope-intercept form, or the y-intercept, right? So I'm finding the y-intercept when I'm finding f of 0. So this is my y-intercept. And then when I'm finding when the function equals 0, remember this is another way of saying y, so this is when y equals 0. So what I'm finding when y equals 0, remember, is that this is my x-intercept. So those are function notation ways of writing the x and the y-intercept. Now the next two questions ask about what is the domain and the range of this function. Now if you'll recall that the domain of a linear function is all real numbers, and so is the range. I can put in any x value and I'll get out every single y value eventually. How they're paired is what's important. So I am going to be able to say in here that my domain in set builder notation, which is what I set up there, is all x's such that x is an element of the real numbers. So remember, this thing means an element of, and then that funky symbol that looks like an R with an X, an extra tail on it, that means all real numbers. So that's the notation. So on my next one, when I want to give the range, I ask for the range on this problem as an interval. So interval notation looks a little bit, remember, like an ordered pair, but it's not. It's saying that I have all real numbers between negative infinity and positive infinity. So that's what the range of this would look like in an interval. All right, now we're moving on to what should be problem number 7, but is noted as problem number 6 on here. So this one should be 7. What we're looking for is using this table of values to give us functions. So this says, what is f of negative 2? So what I'm going to do to find that is I'm going to go find negative 2 for my x, And then I'm going to say, okay, well, what is that value of the function? So remember that y is the f of x value. So this says this is my value when x is equal to -2. So my answer here is 4. Now going to my next one, I have the other value, which is the y value. I have the f of x value, right? And that is this value here. So I'm going to go find this -8, and then I'm going to say, okay, well, that is this value here. So the x that gives me -8 is 6. So that's how I find those. Now moving on to the bottom one down here, which is 7 noted on the homework, but it really should be 8. I have two functions, the f of x function and the g of x function. So I have a quadratic, which is what f of x is, and I have a linear, which is what g of x is. So this g of x function, it's asking me to find when my y value is equal to 0. So y is 0 right here, right? So I'm going to go over here and I'm going to follow it back to my g function. And that x value right there, which is x is equal to 3, is when y is equal to 0. So this is going to be 3. So again, what I did here was I said, okay, follow this back to where it's on the graph, right? So this is when y equals 0. And then I'm asking what is this x value on the function. So that value was 3. So following it back here, oh yeah, the x is 3. When x is 3, y is 0. Now we're going to do that with the f function, but now on the f function, I have the x value in here. So I know when x is equal to 2, where is it on this function? And I want to go back to this value over here and find out what that y is. So I'm going to go from the x-axis and I'm going to find 2, and I'm going to go up until I hit the function, and then I'm going to go back to the y and say, oh, that's y equals 1. So that value right there is 1. And that's how I find the function. All right, now those were all the values that I wanted to, or all the problems that I wanted to do on Chapter 8. So we've covered all of these. Now we're going to move into Chapter 9. So from the Chapter 9 homework, our first problems are 1B and 1C. So let me pull up homework 9 here, and we're going to go to the next page. So on homework number 9, problem number 1B, problem number 1B is this problem here. We want to give the equation of the line with the desired characteristics. The final form of every line must be in slope-intercept form unless it's not possible to write it in that form. Remember that not possible to write it in that form, the only time it's not possible is if it's an x equals line, if it's a vertical line. If a y-intercept is not given, then the point form, slope form must be used, and a graph may not be used to show our work. So if I'm going through this point right here, then I'm not being given a y-intercept because my x here is not 0, that's not my y-intercept. And then I'm being told that it's parallel to this line here. Well, parallel to this is giving me information about my slope. So in order to find the slope of this line and then find the slope of my new line, I have to solve this one for y. So I'm going to have 2y is equal to, and I'm going to have to add 3x to both sides so that I'm solving this for y. So that's going to give me 3x minus 1. And then I finally have to solve it completely for y. So I'm going to divide all the way through by 2. And so that's going to give me that y is equal to 3 halves x and then minus a half. Now I really don't care about that because all that I'm really interested in here is the slope right here. So if I have a line that's parallel to this, the line parallel to this is going to have the exact same slope. So my parallel line slope is also going to be 3 halves. So now I have the slope and I have a point here, And so I'm going to use the point slope form to go ahead and calculate the equation of the line that goes through 4, -3 and has the slope 3/2. So my first task is to use point slope form. Remember that point slope form looks like y minus the y coordinate here, which is 3, and that's equal to my slope, which is 3/2 times x minus, now my x coordinate here, which is a -4, and then I'm going to simplify. So my simplification starts first of all with the distributive property. So this gives me y minus 3 is equal to 3/2 x, and then this is a negative times a negative, which is a positive, so that'll be a positive, and 2 will go into 4 2 times, so 2 times 3, which is 6. And then I'm going to move the 3 over here to finish it up in slope-intercept form, so add 3 to both sides, and that's going to give me that y is equal to 3/2 x plus 9. Now the next thing that I want to make sure that I have done is really found my equation. So to make sure that it's my equation, first of all I'm going to check out the slope and I'm going to see, okay, yes, the slope is 3/2. Yep, I haven't changed that. That's good. Then I'm going to say, well, does it really work for this ordered pair? So when x is -4, so -4, that'd be a -2. -2 times 3 is -6, and -6 plus 9 is 3. Yep, y is 3. So yep, that looks like it's the correct one. And there we go. That would be the equation of my line. All right, now we're going to move on to the next. All right, now moving on to the perpendicular scenario in part C. So if I'm perpendicular to a line, that's telling me again, perpendicular is telling me about slope. So I need to solve this line here for y so I can get the slope. So I'm going to actually add 5y to both sides so that I get the y to be positive. Now, you don't have to do it that way, but that's just the way I'm going to do it. So 2x and then is equal to 5y minus 9. And then I'm going to go ahead and add 9 to this side, so add 9. And so now I have 5y is equal to 2x plus 9. And then I need to get rid of the 5, so I'm going to divide everything through by 5. And now I can see what my slope is. My slope is my numeric coefficient of x. So again, this is my slope. Now this time I need the perpendicular slope. So I need perpendicular. So that means I have to think about what does it mean to have perpendicular slope. And I remember that perpendicular slope is a negative reciprocal. So I'm going to take the negative of that. So that's a positive. So the negative of that would be negative. And then the reciprocal means flip the fraction over. So that's 5/2. So now I have the slope of my new line, and I'm going to look at my ordered pair. Well, that's not the y-intercept, right? That's not 0. So I'm going to have to use that point slope form again. So I'm going to go ahead and I'm going to say y minus y1, so that's a -3, is equal to my slope, that's a -5/2, times x minus, and then my x1, which is -2, and then I'm going to simplify. So distributive property first here, so I'm going to do y plus 3, because a negative and a negative make a positive, and then -5/2, and at that point I go, I did it right. I plugged it in right because it's still a -5/2 slope. Awesome. And then a negative times a negative times a negative is still a negative. And then those 2's are going to cancel, and that's just going to be a 5 then. And then my last step, I need to bring the 3 over. So I'm going to subtract 3 from both sides. And then that's going to give me y is equal to -5/2 x, and then minus 8. And then I'm going to check it out again just like I did before. I'm going to say, okay, now wait a minute. Slope was -5/2. Yep, that's what I said it should have been. That's the negative reciprocal of that. Yep, that's checks. It's perpendicular. Now, this point should be on this line, so let me check that out really quick. My x is -2. -2, and the 2's cancel, so that would be a -1. Negative times a negative is a positive, and that's +5. +5 and -8 is a -3. Yep, that's my y. Awesome. That's the one I wanted. All right, I'm going to go ahead and stop on this video, and I'm going to do one more, I think, to finish it up. So I'll be back with yet one more video.